Hello everyone, welcome back to episode 2, part 1 of explaining physics concepts, and in this video we will be looking at a new chapter, gravitational fields. So if I were to break everything down, this chapter will be covered in these 5 topics. And in this video we will only be looking at gravitational field and the rules to draw fields, Newton's law of gravitation, and the gravitational force x centripetal force. I can ensure you that these 5 topics will cover your entire chapter. Sorry. Starting off with gravitational field and the rules to draw the fields. What do we mean by a gravitational field? We all know what gravity is. Like, it's a force pulling us down. And then we all know what a field is. So whenever we say a word field is essentially a region, any space. So when I say gravitational field, I can write down the definition here. The gravitational field it is a field of force. It is a field, you can write it is a region of force, it is a field of force. It is the force acting per unit mass. It is the force acting per unit mass. So this is gravitational field. So if you know gravitational, when we write this formula, F is equals to ma, a formula that we all know about. F equals ma, here the acceleration of free fall is actually gravitational field. Acceleration of free fall 9.81 is the gravitational field. So I can say G equals F over m. So this is my formula for gravitational field. Now if I want to know the formula, there's another formula that I would love to write here, that is gravitational field strength. So we know gravitational field is F over m. If you want to talk about gravitational field strength, gravitational field strength is Gm over r square. You don't have to learn this formula right now, you will understand it once we do another formula. Now we know what a gravitational field is, and you must have heard about electric fields, magnetic fields, that if there is a magnet like this from positive and then there's negative, so the field lines have to go from positive to negative, and then you just draw fields like that. Similarly, you will have the gravitational fields, and these lines, these rules will also apply to all of the other fields, magnetic fields and electric fields. So I will quickly type them down here, because oftentimes they do give you questions where you have to draw the fields. Number 1, if the field lines are closer, it means more strength. If they are further apart, it means they're weak. If they have equal distance, equally spaced parallel lines, it means they're uniform. Number 4th, if they have to be drawn perpendicular to the surface, they do not cross over. For a uniform For a uniform spherical mass, the field lines are radial. I'll explain all of these through an example. Field lines always point towards the mass, and at a point the direction is determined by a tangent to the field. Okay. Let's just go with the same magnet example that we took earlier. When we have a magnet like this, and when we have to draw the field lines, if they are equally spaced, number one, if they're like very close together, that means they're very strong. Especially if you have an iron core, you will see there's so many field lines inside. That means the magnetic field is very strong. There's similarly that goes with electric fields as well as gravitational fields, and they do not cross over. If you have drawn it like this, you cannot draw one like this. They always have to be separated. And when we say for a uniform spherical mass, field lines are perpendicular, this means that on the surface, it gives you an illusion that they might be parallel. For example, I have a sphere, uniform sphere, and if the field lines are like this, even though they're not parallel, but on the surface it may look like they are parallel, but they will not be. It will just give you an illusion. And at the point, the direction is determined by a tangent. Any point that you take, you just have to draw a tangent and you can find out the direction at that point. Having talked about the gravitational field lines and the rules, we will move towards our next important part, that is Newton's law of gravitation. Now, Newton's law of gravitation says the force of attraction Newton's law of gravitation. It says the force of attraction between 2 point masses. This word point masses is extremely important. Between 2 point masses is directly proportional. It's directly proportional to the product of the masses, and inversely proportional to the square of their separation. Alright. Newton's law of gravitation, the force of attraction between 2 point masses is directly proportional to the product of the masses. So let's assume we have 2 point masses. When we say a point mass is essentially just a uniform sphere. A point mass has to be a uniform sphere. So whenever we say a point mass, that means we're talking about a uniform sphere. So when we take 2 point masses, the force of attraction between these 2 point masses the force is directly proportional. Let's do it step by step. Let's generate a formula through this definition. Is directly proportional to the product of the masses. Let's take this mass as capital M and this mass as M. So to the product of masses, and inversely proportional to the square of their separation. Let's say the square of their separation right here is R, so R square. This is the formula. But if I want to remove this proportionality sign, I need to introduce a constant to make this an equal to sign. So the constant that we will be introducing here is G, gravitational constant, and here the value of G is 6.67 into 10 raised to the power minus 11. This value is usually given, but it's best that you just remember this. So this becomes F equals GMM over R square. One thing I would love to mention here that is usually confused by a lot of students, that is the R here is not just the radius. The R here is the distance between two planets including their radius. Oftentimes students think that it's just the radius, they take that distance, they put that, and they get the wrong answer. But here it is separation. Let me give you an example. Let's say I have a planet here and then I have another planet here, and the distance between these two planets from here till here is, let's say, 10, and its radius is 5 and its radius is 2. The R here will be 5 plus 10 plus 2, 17. Not 5, not 2, not just 10. You have to add all of them because that is the separation distance. So if you look at this formula, this is the Newton's law of gravitation. Now if you talk about the gravitational field strength, that is, since gravitational field strength is of just one planet and you're looking at it separately, that is why we remove one M and you get GM over R square. The formula we generated upstairs here, GM over R square. Here we're talking about 2 point masses. We're talking about the force of attraction between 2 point masses. That is why we have two masses. But when we're talking about just one field strength of just one planet, you just get 1 M. That is why you get GM over R square. And I hope that made sense. Moving on towards our last part of this video, and that is gravitational force x centripetal force. So we just completed our centripetal force chapter, and we have to see how is gravitational force related to centripetal force. So if I were to recall what we did in our last video, centripetal force is just, you can say, a force that is keeping the object moving in that circular motion. Centripetal force is essential for the circular motion, and you know that the planets are orbiting, for example Earth is orbiting around the sun, and so the force that is keeping Earth in that circular motion is centripetal force, and that centripetal force is gravitational force. So let's just assume we have a planet here, and let's see we have another planet orbiting around, and then you see, you know it's orbiting, right? And then you know the reason why it's orbiting and the reason why it's moving around in a circular motion is because it's because of centripetal force. And so there is a centripetal force, and that centripetal force is the gravitational force. So in short words, I will write that gravitational force provides the centripetal force. Gravitational force provides the centripetal force. You know there is gravity, you know there is a centripetal force. The gravitational force is providing that centripetal force. Now how are they related? Blah blah blah. Let's see. Gravitational force. We know gravitational force formula, that is GMM over R square. Now we know centripetal force. We have three formulas for centripetal force. That can be mv square upon r, that can be mr omega square, or that can be mv omega. Here I do not want to use omega, so we will be going with mv squared upon r. So we will have mv squared upon r. Simply you can cut m out, you can cut one r out, and you will have gm over r. You got a formula to find the speed. And whenever they say find speed of an object moving in a circular motion, you use this formula. If this value, it's just an added thing, if this value gm over r, if this value is less than this, the planet that is circulating, it will not be in a circular motion anymore, it will just fly away. This is the escape velocity in simple terms. Escape velocity. And if this value gm over r is greater than v, the planet will crash. Let's just take this example. If gm over r under root is equal to this velocity, it will move in a circular motion. If it is less, it will just fly away into the space. If it is greater than, it will crash. That's it. So we generated our formula by using the formulas we already knew. We generated another formula for the velocity. Just be very mindful of this formula, that you can only use this formula of speed if they have written clearly in the question that it's in a circular motion. Now another formula that we can derive, and that is known as Kepler's third law of gravitation. Kepler's third law of gravitation. Newton's law of gravitation, Kepler's third law of gravitation is just a way of finding relations and seeing what depends on what. Let's see. In all of them, all of these, gravitation law, they use the formula that we already know. Let's see. In this, we are going to use the gravitational force, again gmm over r square, and again we are going to use a centripetal force formula, but in this time we will be using mr omega square. In last case, for the centripetal, we used mv square upon r. Here we will use mr omega square. Now I can cut this becomes r cube gm r cube omega square, and then you have we know what omega is. Omega is 2 pi f or 2 pi by t. So when you get 2 pi by t whole square, you get 4 pi square over t square, and then you get t square gm equals r cube 4 pi square. Now, are you able to identify the constants here? I'm sorry. The constants in this formula, g and m. G is 6.67 in 10 to minus 11. Mass of the object will remain constant, it will not change, and 4 pi square is also a constant. So whenever you have constants and there's an equal sign, and if I just remove those constants, what are we left with? This. We are left with this. The reason why I was able to remove this proportionality sign is because I was able to add these constants, but once I remove these constants, I get this relation. So the entire purpose of Kepler's third law of gravitation was to make you understand that time constants, that time, it only depends upon the distance. When you're looking at the relationship between centripetal force and the gravitational force, you get to see that time only depends on distance. That is it. The time it takes to complete the circular motion, it only depends upon the distance. That's it. And that is it for the part 1 of this video. Thank